All over the world, businesses are turning to satellite-based tracking and fleet management solutions to cut costs, increase revenue, improve service offering, increase operational efficiency, and protect their brand reputations. Owing to rising crime rates, users are embracing GPS tracking solutions as fallback plans to aid the recovery of stolen assets. Are you an entrepreneur or aspiring to be one? Are you eager to start a lucrative tracking business? You will acquire the knowledge and skills to offer professional-level tracking services in this course. Perhaps you are career-oriented, probably working in the logistics sector or still seeking employment in this sector. Experience in vehicle telematics and fleet management systems has become a key requirement in securing lucrative jobs at logistics companies in recent time. This course and the certificate you will acquire by completing it will prepare you for an exciting career as fleet manager or fleet supervisor, transportation manager or transportation coordinator, fleet tracking officer, and more. Even if you are a technical person or marketing expert looking to generate additional income stream, or you are just a curious mind seeking in-depth understanding of satellite-based tracking and fleet management systems, you will find this course very resourceful. Hi, I am Richard Ofozi, an industry-recognized IoT specialist with over a decade experience implementing and managing both front-end and back-end IoT systems for corporate bodies and individuals seeking to unlock the full potentials of IoT in securing their valuable assets, reducing fleet expenses, while improving fleet operational efficiency. In this course, I will introduce you to satellite-based vehicle tracking and fleet management system. The IoT devices, sensors, and systems used in rendering vehicle tracking, asset tracking, and fleet management services. How to install tracking devices on automobiles and fuel monitoring systems. Knowledge of modern automotive electrical system and basic electrical theories and principles and how they relate to automobile electrical systems are rudimentary to mastering how to install aftermarket telematics devices and sensors on vehicles. These will all be covered in this course. Hello. Welcome to the course. In this module, I will introduce you to satellite navigation systems, the IoT devices, sensors, and other systems used in rendering vehicle tracking, asset tracking, and fleet management services. Wondering what IoT means? IoT is the acronym for Internet of Things. IoT refers to a system of internet-connected devices other than our regular smartphones and computers. Tracking devices are typical examples of IoT devices which enable us to connect vehicles and assets of value to the internet. Why connect vehicles to the internet? Connecting vehicles to the internet serves various purposes, such as data retrieval or monitoring purpose, control purpose, automation purpose, and communication purpose. By connecting vehicles and assets to the internet, we are able to keep an eye on them as we can monitor their whereabouts remotely, that is, their real-time locations. Aside from vehicle location data, we can also fetch other data pertaining to vehicle usage. This may include vehicle speed, odometer reading, and engine speed, fuel level, diagnostic fault codes, among others. Similarly, we can monitor drivers' behaviors and driving habits behind wheels, as well as other happenings within or around vehicle. Tracking devices not only provide vehicle and asset visibility, but also provide the means through which users can exercise control over certain vehicle functions, like immobilizing vehicles remotely through structured commands sent via SMS or GPRS network. IoT, or to be more precise, Internet of Vehicles, IOV, has made the automation of dispatch process possible in recent years. Vehicle preventive maintenance scheduling is now being automated. Keeping track of vehicle maintenance due time is no longer the daunting task it used to be. Fleet supervisors no longer have to go through the hassle of maintaining record of mileage covered by each vehicle on his fleet on per-trip basis. Logistics companies, ambulance service providers, taxi companies, among others, are all making extensive use of vehicle tracking systems in assigning vehicles to jobs and keeping track of vehicle maintenance due time based on actual vehicle usage, using parameters like mileage and engine running time. On some occasions, IOV devices provide the means through which users can communicate with drivers and certain automotive systems. So, how does it work? At the front end, a tracking device is installed or embedded on the vehicle or asset being tracked. The embedded tracking unit picks up and analyzes signals constantly being emitted by navigation satellites from outer space to ascertain the precise location of the vehicle or asset being tracked. What the tracking unit does next with this data depends on the model implemented, whether device server client model or device client model. Under the device server client implementation, the tracking unit forwards the location data at preset intervals through a communication network to a backend server, which stores the received data on a database, only to be served to an authorized user, often called the client on demand. This is the famous real-time web-based tracking solution that enables users monitor tracked vehicles and assets on browsers and mobile tracking apps while offering users trip replay feature. Under the device client implementation, the tracking unit will forward the location data to an authorized user as an SMS feedback in response to a structured user query sent to the tracking unit as SMS through the cellular network. I will refer to this model as the standalone SMS-based tracking solution, which is popular for its lower cost and no annual premium offering. Various systems and infrastructures are employed in rendering vehicle tracking and fleet management service. Among these are space infrastructure, which is made up of the satellite navigation systems, also known as SatNav systems, such as the Global Positioning System, GPS, GLONASS, BeiDou, Galileo, among others. Receivers and sensors. That is, the tracking units and the aftermarket sensors, which may be installed in vehicles to achieve user-specific outcomes. Communication infrastructures, which provide the channel through which the tracking device, tracking server, and the client communicate. The tracking servers. These include both the physical server machine or data centers and the backend tracking software that is hosted on the server. Geocoding or mapping systems, and the client. Next, I will discuss further on each of these systems and infrastructures employed in tracking of objects, starting with space infrastructure, which is the underlying technology that makes precise positioning of objects possible. Space infrastructure is made up of satellite-based radio navigation systems, sometimes called the SatNav systems, such as the famous Global Positioning System, GPS, owned by the US government, and its various alternatives, which include GLONASS, owned by the Russian government, BeiDou, owned by the Chinese government, Galileo, owned by the European Union, Quasi-Zenith Satellite System, QZSS, a regional SatNav system, owned by Japanese government, and India Regional Navigation Satellite System, IRNSS, another regional SatNav system owned by Indian government. GPS, like the other SatNav systems, are a constellation of satellites, arranged at various orbits in outer space, such that, no matter where you are, on planet Earth, signals from at least 4 of these satellites are available to you, so long there are no obstructions, shielding you from the open sky. Because we cannot see these signals, we need receivers to pick up and analyze these weak SatNav signals, and provide us with location data, usually in the form of longitude, latitude, and altitude. This is analogous to the same way we would need radio sets to listen to radio broadcasts from our favorite FM stations. Tracking devices or receivers are electronic units, which are capable of processing weak radio navigation signals emitted by navigation satellites to provide precise location of persons or objects, such as vehicles, and other valuables, to which they are attached. Receivers are named after the SatNav signal they process. GPS tracking device or GPS receiver are receivers designed to process GPS signals. Similarly, a GLONASS receiver will process signals from GLONASS, while BEDO receivers are designed to process radio navigation signals from BEDO navigation satellite system. GPS is the first and most famous sat-nav system, having rendered positioning service for about 2 decades prior to the year 2012, when GLONASS attained global coverage. It is therefore common to hear users, many of whom are not aware of the existence of GPS alternatives, refer to every tracking device available in the market as GPS tracking device. Multi-sat-nav or multi-GNSS receivers, capable of processing signals from 2 or more sat-nav systems, are gaining popularity in recent time. Why have tracking devices that support multiple sat-nav systems? GPS is a military technology developed and managed by the United States Department of Defense. The deliberate degradation of GPS signal for civilian users between year 1993 to 2000 through the practice of selective availability and the claim that the US government denied Indian military access to GPS during Kargil War of 1999 have risen users' concerns that the US government can deny any country or region access to GPS service whenever they choose to. Multi-sat-nav receivers, capable of processing signals from multiple sat-nav systems, is bought for precautionary reasons, to protect users against GPS access denial, while also guarding against the unlikely incidence of GPS service failure. Aside from this precautionary reason, multi-sat-nav or multi-GNSS receivers provide more precise positions, since more navigation satellites are visible to them at all times. To satisfy the different needs of various users, sat-nav receivers come in different forms. Some come as handheld devices with or without LCD screens and SD card supports for logging location data. You will often find this kind of receivers with geographers, geologists, environmental scientists, among others. These kind of receivers are called data loggers. The very kind of receivers we employ in vehicle and asset tracking come as dedicated tracking units, able to push updates to users via SMS or to a backend server or data center via GPRS network at preset intervals. These kind of receivers come with inbuilt communication module, which could be GSM module, satellite communication module, Wi-Fi, or Bluetooth module. We call this type of receivers data pushers. Also, we have the data pullers, which are mostly electronics units designed to serve other primary functions, but have sat-nav modules for extended functionalities. Smartphones, laptops, and tablets are typical examples of data pullers. With the right software, data pullers can be made to function as data pushers. A typical example is the Uber Drivers app that makes drivers' smartphones to function like a vehicle tracking device or data pusher. Communication infrastructure provides various channels through which tracking devices can send updates on vehicle or asset locations to the tracking server or data centers. The tracking device is also queried through these communication channels. Depending on the capabilities of the tracking device, data can be transmitted to the server in one of several ways. Cellular network, satellite communication network, Wi-Fi, and Bluetooth networks are typical channels through which tracking devices can push updates to a backend server. Cellular network is so far the most common method of transmitting data to the tracking server. The GPS tracking device contains a GPRS modem, which typically uses a SIM card provided by a wireless data provider like MTN, Glo, Airtel, 9Mobile, among others. The modem uses this wireless data plan to establish a connection to the internet and then a socket connection with the server. Once connected to the server, it typically sends its location information, then disconnects. Data can be transmitted using TCP, which stands for Transmission Control Protocol, or UDP, which stands for User Datagram Protocol. In some cases, data may be sent to the server using SMS via an SMS gateway. The GPS tracking device may be equipped with a satellite modem, which connects to one of the major satellite communication data providers, like Iridium, Obcom, Globalstar, among others. in which case, data from the tracking device is sent to an orbiting communication satellite, which then relays the data to a ground station, which in turn forwards the data to a server over a standard socket connection. Satellite data communications have slower data transfer rates. They are much more expensive and have much greater data limitations than using a cellular network. Cellular networks cover around only 10% of the world. Satellite communication network allows us to reach the other 90%, making it realizable for asset tracking solutions to achieve virtually 100% global coverage. Certain tracking devices, like the AT5 and AU7 models multi-GNSS tracking devices that work with both GPS and GLONASS, offered by A-Track Technology Incorporated, Taiwan, employ a hybrid connectivity to combine the benefits of satellite coverage with lower cost of cellular network communication. A-Track AT5 and AU7 model devices use Iridium SBD modem to ensure an always-on data connection and zero downtime. These devices are equipped with intelligent control units, with which they automatically switch between cellular and satellite networks to minimize data transmission costs, while making sure the trackers are online at all times. By default, these tracking devices will use the cellular network for two-way communication with the tracking server. When cellular network is unavailable, the tracking device will automatically switch to data transmission via Iridium network. The GPS tracking device may contain an IEEE 800 and 2.11 compliant Wi-Fi modem, which connects to a wireless router to send data to the server. This type of application is typically limited to localized environments, such as tracking vehicles traveling within a closed yard, like a manufacturing plant or factory, a closed estate, a mining plant, among others. The advantage with this solution is that there is no associated cost with the tracking of the vehicle aside from the initial investment. However, the coverage area is limited to a very specific geographical area with Wi-Fi network. The GPS tracking device may contain a Bluetooth modem, which it uses to connect to a local Bluetooth-enabled server or router to send data to the server. This type of application tends to be used only in very customized applications. Tracking servers include the physical server machine or virtual machine (VM) available as a cloud service, and the backend tracking software. The physical server machine or virtual machine hosts the backend tracking software and the database. The backend tracking software receives data from the tracking device embedded in vehicles and other valuable assets at the front end. It securely stores the received data in database and serves this information on demand to the client or user. Tracking devices provide location of vehicles and assets being tracked in the form of position coordinates. Position coordinates are a unique set of numbers which describe a location point as longitude, latitude, and altitude. The problem with this is that we humans cannot make sense of location coordinates given as longitude, latitude, and altitude on our own without making reference to a map. For instance, if I told you my location is longitude 6.613774, latitude 3.358014, I can bet you wouldn't decode this as a location around Ikeja City Mall, Lagos, Nigeria, unaided. We need geocoding systems to make sense of the position coordinates provided by tracking units. The process of converting location coordinates into human-readable addresses is what we call reverse geocoding. This is where Google Maps, Microsoft Bing Maps, OpenStreetMaps, and other mapping systems come to our rescue. Tracking software and mobile tracking apps are designed to make API calls to Google Maps or other third-party mapping systems in the background, displaying mapped interface where position coordinates provided by tracking units are pinned to corresponding positions on the map. The client refers to the various devices and software through which users interact with the tracking devices and access data stored on the database hosted on the tracking server. Browsers such as Mozilla Firefox, Google Chrome, Internet Explorer, and mobile tracking apps like CityWatch Mobile Tracking App, Tracker Manager, and XGPS Monitor by Navixie all constitute the client. The client performs three major functions. These functions include data retrieval, data processing, and data presentation. The client device is responsible for data retrieval from the database hosted on the tracking server. Usually, the client retrieves data stored on the database by placing a HTTP request call to the tracking server. Usually the client performs data processing functions, such as connecting to third-party geocoding applications, like Google Maps, through API, to turn coordinates to actual addresses. The client is also saddled with the responsibility of presenting the retrieved data in ways that are meaningful to the user.